All right, so we've done our activity in class using Desmos, kind of analyzing Vertex form and how to interpret the different translations that we see. So just to put down some final words, giving us some definition, A is referring to the value that's outside and multiplying, okay? And it represents the width of the graph is another way of thinking about it. And so it can either stretch or compress that width. Okay, so stretching, meaning that it gets narrow, and compressing gets wider. I always like to think of this as like being with putty, because when we kind of go to stretch it out, the putty itself gets thinner in the middle, and if we went to squish it back all together, then we get kind of a big fat ball. And the direction it opens is also indicated by this A value. It can either open up or down. Okay, so if A is bigger than 0, and it doesn't matter, or bigger than 1, and so you see these lines, they mean absolute values, so that doesn't matter whether it's positive or negative. The magnitude of it is 2, 3, 4, 5, 6, etc. It's bigger than 1. Then the graph will be stretched. And so it will be narrower. Okay. If we're dealing with a fraction as a value here, so between 0 and 1, either written as a fraction or written as a decimal, then we are dealing with a compression. So it will be wide. Okay. If A is less than 0, so if A is negative, if this value here has a negative in front of it, then we are dealing with a parabola that is going to open downward. So these are all characteristics that you can get from that number out in front. P is our next value that is actually written as a constant. Okay, so A, P, and Q are going to be represented by numbers when we actually write a quadratic function in Vertex form. So for example, if we're looking at y equals negative 2, x minus 4 squared plus 5. Okay, so this is A. It means we're going to be opening downward because it's negative, and it's going to be stretched, so it's going to be a narrow parabola. P is our second value here. It gives us our x coordinate of our vertex. It also tells us basically how it shifts. Okay, so what does that look like? Well, it represents the horizontal shift of the graph. So if P is positive, the graph will shift to the right. And if we think about on our graph, our x and y axis, horizontal going positive is this way. Okay, so shift right. And if P is negative, the graph will shift left. So if we look at our example again, we see, okay, well, it's subtract 4. So on first instinct, we're like, okay, so shift left 4. But if we go back to the original general or kind of like summary form of it, it's actually subtracting in the formula. So this negative is not attached to P. P is actually just 4 in this case. And so our horizontal shift almost seems like it's opposite. The sign that we see in the equation, because that negative is already present in the formula. Finally, Q, we see it here. We're talking about P, we're talking about Q now. It's on the outside of that square. In our example here, it's positive 5. Q represents the vertical shift of the graph. If Q is positive, the graph will shift upwards. But if the Q is negative, the graph will shift downwards. If we look at this example that we have on the right-hand side, we've got positive 5, so that means that it's shifted up, positive 5. We said P is positive 4, so it's shifted over here. It's opening downward, and it's going to be negative, or it's narrow. So our parabola is going to look something like that, and this is just a rough sketch. Okay. In actuality, whenever you go to graph something, you would want to have some defined points at least to give you some relative context. But just for the general wrapping our head around this, that's how we can sketch it out. So we've got A, P, and Q in terms of their transformations. That's how we've defined it here. Okay, so transformations. Okay, and what that means is basically just how is my parent function going to move around the graph? Again, my parent function being always relative to y equals just plain old x squared. Another way of looking at vertex form, and this is where it gets its name, is that P and Q, when written as a coordinate, which is down here at the bottom of your screen, that actually represents the position of the vertex. So we saw that again over here. My position here is positive 4 and 5 at the vertex, that maximum or minimum point on my parabola. So that's another way that we can use vertex form.